So now come up with the table as specified with respect to age, competition and type. The probability of that is yes, P and no, probability of yes and probability of no.
Can you repeat it again, ma'am? We have to, in terms of yes or no, or up or down, ma'am?
Yes. So with respect to age, I want old, mid and new. With respect to positives, negatives, that is down and up. I can write it as this is down
Okay,
and
ma'am. Got
up.
it.
Okay. And P of
So we're
down.
taking down and up because it's not specified anything in the question.
Exactly. So we are going to consider the last column as our classification. That is a class of categories for our classification problem. So this will be my target or labels. So P of
Got it, ma'am.
up. Now I want you to come up with this table for A, for competition and for type.
Excuse me, ma'am.
Yes.
Could we also use yes or no, ma'am? Like instead of up and down?
When it is
Like in the
specified,
previous.
yes, when it is specified, take competition as the classification to predict your probabilities, then you can go ahead with that. I wanted you to change because we already have seen the yes, no category in the previous example. That's why I've actually changed it to profit this time.
Okay, ma'am.
I want you to understand, okay, how are you going to apply naive-Bayes classifier with any attribute that's given to you? See, a profit is again one attribute, competition is one attribute, type is one attribute, age is one attribute. They are all the four forms an instance. Any instance that is given to you, you have to come up with the correct prediction. So it can be any attribute that is being classified according to its own attribute values, right? So you can consider
Yes.
anything, but the target value is very important for you to perform your predictions. You agree with me? Target values is
Yes.
only the one you'll be using to perform predictions. So you can take anything until and unless it is specified. That's why this time I made profit as the prediction to make sure how you can apply any instance that is given to you with respect to any attribute, how you can come up with a solution.
Okay, ma'am. Thank you, ma'am.
Yes, you're done? You need some more time?
Done.
We can go ahead?
Yes, ma'am.
Okay. So now from here, see, this is what the tables that I've got. I've written it over here. So calculate the probabilities of class attribute. Yes, probability of up with the whole data, it is 5 by 10 and 5 by 10. I've written there. And this is the probability values of all three data sets. Age, competition, and type. Okay, now what we have to do is the given instances, whatever they have told, okay, that instance is what I have to consider. So what I'll do is I use the base formula to find out it. So basically base formula is I'm going to write it as P of xi. The given instance, the first attribute of it, again, I2, I3 of x. Okay, this is the actual formula. If you remember, this is the actual formula. This is the split up. An example is what we are trying out, but this is the actual formula. Probability of, I have an instance, I1, I2, I3, I4, I5, 5 instance, like 5 attribute values in one instance, that is x. So probability of I1 with respect to x, I2 with respect to x, I3 with respect to x, I4 with respect to x, so on up to any values it has, In with respect to x is what I will be calculating it now. So probability of up. Probability of up. What is the probability of old with respect to up? So our instance was old. What was our instance? Old. Yes. And hardware, right? This is my test instance now, right?
Yes, ma'am.
So from my test instance, I have to calculate the probability of whether this given test instance is going to be classified under the class yes, that is up or down, right? So for that, what will be writing? Probability of old with respect to up, probability of yes with respect to up, probability of hardware with respect to up. So we know probability of old with respect to up. What is the value of it?
0.
0. Probability of yes with respect to up? 1 by 5. Probability of hardware with respect to up? 2 by 5. When I multiply it with 0, it is going to be 0. Yes. So next, we'll go ahead. Probability of down. So what will be the probability of down? Can you let me know the answer? So it's going to be probability of old with respect to down, probability of yes with respect to down, probability of hardware with respect to down. Substitute the values of it and get me the answer. What is the value?
Ma'am, is it 0.144?
Exactly true. It's 0.144. So when we compare it, probability of up is 0, probability of down is 0.0114. You need not normalize it because again, it's the same other term, you will get it. So no need to normalize because you have one value as 0. So no normalization. You can directly come to a conclusion telling that the test instances with respect to old yes and hardware that you have given, the probability of that to be classified according to the test data is probability of down. Getting this? Yes. See here, it is going to be probability
when is
of
it
down.
necessary? When is it necessary and not necessary to do the normalization?
When one of the term is 0, you need not perform normalization. This term is 0. In the previous example, you had both the terms of value. So you apply a normalization for that to get the accurate value of it. But here, since already one of the term is 0, you need not perform normalization. What are you going to do? 0 divided by 0 plus 0.114 or 1.114 divided by 0 plus 114. You'll get the same answer, right? So you need not perform the normalization. So instead, you can directly write it as telling this given test instance is having more probable towards the down, profit down. Okay.